Let me catch up to you just a little bit. I want to. So is everybody able to do this first one? If you're not, just see me or Well, here, real quick. Here's the. All right. So here's when you take this guy's derivative, the 4 comes down, and now it's to a third power times this guy, plus the 5 comes down, but then the derivative of the inside is 2. Chain rule, right? So you get 10 times all 4 of those and 1 less of those. Is that first step decent? That's just product rule with the chain rule, because that 2x plus 3, the derivative of that inside's got to come out. Why didn't it happen for this guy? Well, it did. The derivative of the inside of that is 1. So 1 times 4 is 4. Hey. So the chain rule really always happens. It just only shows up when the inside is more than just x. And now I just start to factor, right? A 2 comes out of both. I could take 3x minus 3's out. And I could take 4 2x plus 3's out. So I'll have 4 times a 2x plus 3. Sorry, 2 times a 2x plus 3, that's 4x plus 6. And I'll have 5 times an x minus 3, that's 5x minus 15. Is that all right? Most of you guys, that's right. And then you just put stuff together on the inside. You get 9x minus 9, and then you can factor a 9 out with a 2 makes an 18. So I think the part where a lot of people trip up is from here to there. But that cannot be hard. It's GCF. Right? I don't mean to make you feel totally bad if you're not able to do that, but you should feel a little bad. Sorry, if that's me coming off as an asshole, too bad. Because that's so really it truly is just take a 2 out because it comes out of both numbers. Take 3x minus 3's out because they both have 3x minus 3's. Take 4x 2x plus 3's out because they both have 4 2x plus 3's. And then writing what's left. How are we doing there, you guys? So why do I have a 4x plus 6? Because it would be a 2 and 1 2x plus 3 left, right? 2 times 2x plus 3 is 4x plus 6. And here, what would be left? A 5. 2 it goes into 10 5 times. And 1x minus 3 would be left, right? Because I took out all 4 of those guys. And I took out 3 of these guys, so there's 1 left. 5 times x times negative 3, 5x minus 15. Put that stuff together. There's your third little packet that gives you a critical point, right? A critical number. So you should get 3, negative 3 halves, and 1. Okay, so our critical numbers are 3, negative 3 halves, and 1. You can see that from here. Bam, bam, bam. And again, if you have a lot of trouble with this, don't waste a bunch of time on this. Just start to do the rest of them with the right answer. Come back to it if you have time later. Right? Sign diagram. So I make my little... All I care about are these points. Put them in the right order, of course. I always love when that happens. Somehow 3 is below negative 3 halves. That's always trippy. So you got to check. So you have to come in here understanding this. This is a nice continuous function, right? It's a polynomial. It's beautiful. The only time it can change... This is the slope, though, right? So the only time it can change sign is when it goes through the x-axis. And we've already identified everywhere it does that. So if I choose any point in between 1 and 3, let's say, and it comes out, well, let's see. If I choose 2 and I plug it in, what do I get when I plug a 2 into all this business? Yeah, it comes out negative. It's going to be negative in the whole, it's going to be a negative slope of the whole place, because if it changed sign somewhere in there, there should have been another intercept in between those two, and there ain't. We already identified all the intercepts. That's why I can do this like this. Just have to check one thing in there for an infinite number of numbers. It's fine. Because it's in between the 2 doors. Those are doors to get through the x-axis. I like to think of it that way. Now here's the multiplicity thing coming to help me out. Now I could just plug 4 in, I could plug 0 in, I could plug negative 18 billion in, or whatever. Maybe negative 2. But instead, I'm going to go, okay, 3 came from something with an odd multiplicity. It's going to change signs. 1 came from something with an odd multiplicity, it's going to change signs. Negative 3/2 came from something with an even multiplicity, it's going to stay the same sign. That's how multiplicity helps you. Makes that so much clearer. If you don't understand multiplicity, you can still just plug each thing in. You're fine. The less you know, the more you got to do. Yes?
I have a question. Above 1, what is that symbol?
Oh, it's a Z for 0.
It's a Z.
I just always do that for myself to remind me that it's 0 at that point. Or I put a little U for undefined.
Are the other ones Z too?
Yes, they're also Z's. So it's really just Z or U I put up there. It helps me for when I go to graph it. I can just see really quickly, is it supposed to be like a 0 place where it doesn't freak out, or is it like undefined? Is it supposed to have some kind of infinite slope or something else freaky there? Just, you don't have to do that.
So you're basically saying it's just where it's 0.
That's where the slope is 0. Or I put a U if it's undefined there. Then I know something really freaky is happening there. Yeah.
On the test, would we be required to actually make that sign diagram?
Oh, yeah. Okay. So now I ask you this question, which is really the same as what we were doing earlier, and then I ask you this new question, which really shouldn't be that big of a deal. Let's do this new question first. Where is this function increasing? It's going to be where the slope is positive. So then I just got to give me intervals where that's true. So where is it increasing? What intervals is it increasing on? Negative infinity? No. To negative 3/2. Is it increasing at negative 3/2? No, it's resting at negative 3/2, right? It's like, yes. So you can't include that in your interval of increasing because it's not increasing or decreasing at negative 3/2. Or, where else? Negative 3/2 up to 1, just to complete that out. Or 3 to infinity. I love it. Where is it decreasing? The only one left, 1 to 3, where it's negative slope, 1 to 3, that's where it's decreasing. Become a 3. Okay. How are we feeling right now? We are tired, groggy, confused. Sounds about right. Okay. So now is there a max in this thing somewhere? At 1, I love it because it's going up to it and down from it, so that just makes so much sense that that's a maximum. And so where's the maximum? It's going to max at what? 1, what? This is where the output is stupid big. I got 16 times 5 to the 5th, and I was too lazy to get my calculator. I think it's 50,000. Okay? 50,000. Woohoo! And there's a min where? A min at 3. This one's nice. Where are you putting that in, by the way? Where are you putting a 1? In the actual function, because I want to know what the output is, not what the slope is. I know what the slope at 1 is. Why would I do that again? So 3, I'm going to plug it in here, and of course then I get 0. There's a min 30, there's a max 1, 50,000. I like it. That makes the next part a little bit easier. I'll bet you anything it's going to be absolute max. 1 is on that interval, right? So I have to check f of 0. I got to check f of 2. I got to check the critical point that happens in between 0 and 2, which is 1. And no other critical points happens between 0 and 2. Is that cool? So I always have people do more work than they need to. You only check the ones that are in that interval. So f of 0, I got like I got positive 3 to the 9th, whatever the hell that is. Again, I was too lazy to get my f of 2, I got 7 to the 5th. Is that right? 2, yeah. 7 to the 5th. And f of 1, of course, was the 50,000. So now it all depends on what those other things are. Three to the 9th is like 9 times 9 to the 4th. Which one? 3 to the 9th? 19? 13,000? 19,680. 83, okay. 7 to the 5th?
16,008 or something.
I like it. So there's an absolute min there, and an absolute max there. On that interval. So the function can get lower than that, but on that interval, that's where the absolute min is. So if I ask you, which one of these is easier to do, C or D? I would expect most people to say D. But some of you guys are saying C, which I have mixed emotions about. Makes me happy and confused. But okay, all right. Whichever way you feel about it, you got to do both. Have you guys done number 2 yet? Probably not most of you. Okay, I'll give you some more time for number 2. Number 2 is a nifty looking thing.